Lesson 8-6 Practice. The addition rule. Question 1. This question has two parts. First answer part A, then answer part B. Part A. The table displays the number and type of tickets bought for a play that was performed in both the afternoon and evening. Drag each probability to the appropriate description. Alright, probability that it is a child ticket or afternoon performance. If it's a child ticket, that would be 36 plus 12, 48. And to add to that, the afternoon performance, again, we wouldn't add the 36 again, we would add 127, so 48 plus 127 is 175 over 363. Probability that it is a child ticket, we already talked about that. 36 plus 12 is 48 out of 363. Probability that it's an afternoon performance. The afternoon performance would be 36 plus 127. 36 plus 127 would be 163 out of 363. And finally, the probability that it's a child ticket and an afternoon performance, that's only 36 out of 363. Part B. The addition rule states for the given events A and B, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Apply the addition rule for the events a child ticket is bought for a play and the play is performed in the afternoon. Using the addition rule, the probability that it's A or B, that was 175 over 363. Equals the probability of A was 48 over 363. Plus the probability of B. The probability of B was 163 over 363. Minus the probability of A and B. And that was 36. No, that was 175 over, it was 36 over 363. Question 2. A biologist studies two different invasive species, purple loosestrife and common reed, at sites in both wetland and coastal habitats. Purple loosestrife is present in 35% of the sites. Common reed is present in 55% of the sites. Both purple loosestrife and common reed are present at 23% of the sites. What percentage of the sites have purple loosestrife or common reed present? Well, the probability of A was 35 plus. The probability of B was 55. And then it's minus the probability of purple loosestrife and common reed minus 23. You can see that's 67%. Question 3. The question has two parts. First answer part A, then answer part B. 30 teachers and students participate in a student faculty basketball game as a fundraiser. They are surveyed after the game by the sports medicine class to find out how many of them stretched before the game. The results of the survey are shown in the table. One of the sports medicine students, Han, wants to know the probability that one of the participants in the game selected at random is younger than 18 years old or stretched before the game. To figure this out, he adds three values in the first row, 5, 9, and 4, to the values listed under the heading younger than 18, 5, and 10. He then divides the answer by 30 and obtains the probability of 33 over 30. He realizes that 33 divided by 30 is greater than 1 and determines that he must have made a mistake. What is Hans' mistake? Hans' mistake happens when he adds 5 plus 9 plus 4 plus 5 plus 10. He counted the value 5 twice. He counted it once for the people who were younger than 18 and again for those who stretched before the game. How does the addition rule account for this kind of mistake? The addition rule tells you to subtract probability of A and B after adding probability of A and B to find probability of A or B. Complete the following. In this situation, event A was player was less than 18 years old. And event B was player was stretched before the game. The addition rule helps Han not to count players who were younger than that stretch and were younger than 18 years old twice. Question 4. Two classes of elementary school students were asked what activity they wanted to do during recess. Each student selects one recess option. The table summarizes the recess preference of each student in the class. Write your answers as simplified fractions in the form A divided by B. What is the probability that a student selected at random prefers to play tag at recess? All right, there was 9 people that liked to play tag. And how many is there total? 18, 19, 20, 30, 40. There are 40. 9 40ths cannot be reduced. What is the probability that a student selected at random prefers to play tag or kickball at recess? Tag or kickball. 9, 18, 23. 2 plus 7 is 9, 9 plus 9, 18 plus 5 is 23 40ths. Again, cannot be reduced. What is the probability that a student in class A selected at random prefers to play kickball at recess? Okay, so there are 18 people in class A, 2 plus 7 plus 9. How many likes to play kickball? 9 of them. 9 out of 18 is the same as 1/2. What is the probability that a student selected at random is in class B and prefers to play tag? If they are in class B and prefers to play tag, that's 7 people out of 40. 7 40ths. Question 5. How many student picks a random letter from the word dog and a random letter from the word barks? How many outcomes are in the sample space? Well, dog has 3 letters and barks has 5. 3 times 5 is 15. There are 15 outcomes. What is the probability that is chosen? Well, there is a 1 out of 3 probability that was chosen in the word dog. 1/3. What is the probability that A is chosen? Write your answer as a simplified fraction. So there are 5 letters in the word bark, so 1/5. There's 1K out of 5 letters in the word bark. What is the probability that O and K are chosen? Well, there's only one way. You select O from the word dog and you select K from the word barks. So there's only one way to do that out of the 15 outcomes, 1/15. Question 6. This question has 2 parts. First answer part A and then part B. The table shows information from a survey about the resting heart rate in beats per minute for 200 college students who are in marching band and who are not in the marching band. All right, create a two-way table that shows the relative frequency for each of the values in the table relative to all 200 people in the survey. Write each answer in decimal form. All right, so the first one in the marching band below 80 would be 56 out of 200. That would we would cut it in half to make it out of 100, which would give us our decimal. Half of 56 is 28, so 28 divided by 100 is 0.28. 0.28, let's do that, 0.28. All right, the next one is 66, so that's 0.3. Half of 66 is 33 divided by 100 is 0.33. Half of 122 would be 61, 0.61. Half of 28 would be 14, 0.14. Half of 50 is 25, 0.25. Half of 78 is 39, 0.39. Half of 200 is 100. 100 divided by 100 is 1. Half of 84 is 42, 0.42. Half of 116 is 58, 0.58. Answer in decimal form. What is the probability that a person surveyed selected at random has a heart rate above 80 or is in the marching band? Above 80 or is in the marching band. Right, above 80 would be 14% and 25%. And in the marching band, we wouldn't count the 14% again, just the 28%. That's 67%, 0.67. And then finally, what is the probability that a person surveyed selected at random has a heart rate below 80 and not in the marching band? Below 80 and not in the marching band is 33%. Is that the last question? No. Question 7. The circle in the image has divided into congruent sectors. What is the measure of the central angle of the region in radians? All right, so the whole circle is 360 degrees. 2/3 is shaded. 2/3 of 360 is 240. So 240 degrees to radians, that would be 240 times pi over 180. That would be 240 pi over 180. It's the same as 24 pi over 18. You could divide both of those by 6. That would be 3. And that would be 4 pi over 3.